Yeah.
All right. Okay. So we're gonna talk about WebSockets. There's a beautiful video I have to share as well, but let's start now. Okay. This is a great slideshow. I'm actually gonna pause because we're gonna go into a video in a minute. So, all right. Why are my wait? When did they? Oh, this is just a really long transition. So
Hello,
okay.
Jonah.
So yeah, obviously you can see this was not made for today because it's April 7th and not October 15th. But we're talking about WebSockets, which is Oprah's favorite programming topic because you get a WebSocket and you get a WebSocket and everyone gets a WebSocket. It's actually really funny that we're doing this because I'm doing a project for Jesse's other class that is WebSockets right now. So
What if I don't want a WebSocket?
you don't have a choice. You get a WebSocket. All right, so let's talk about this. This you may or may not be familiar with this thing, but this is the model view controller schema, right? We've got some important things here. So, can somebody in chat tell me if you guys have gone over MVC? If not, then we'll teach it real quick because it's kind of important to understand where WebSockets and actors fit in and what their differences are. I think we have, but can you do a quick research? NPC, no, MVC.
MVC, yeah.
Okay.
MPC,
okay. A bunch of people don't remember. Let's go over it again. MVC, Model View Controller. It's 3 parts in any program. You've got your view, which is what you see. Your controller, which is how you control the things that you see. And the model, which is the stuff that controls the things that you see. No, which is the thing that takes the controller input and turns it into things you see. Okay? That might sound a little bit confusing.'re going to turn this to an example of an Xbox. Please tell me I have it on the next slide. I do. Oh my god. I'm just an absolute genius. I knew this slide existed in one of the presentations somewhere, and I was hoping it was this one.
Hello, Xbox.
Let's talk about model view controller for a second. In this case, right? So this is generally how you play a video game system, right? You've got a controller, you've got a console, and you got a TV to view it on, right? So your controller is going to be your Xbox controller, obviously. It's how you control, it's how you give input into the system. Your model is going to be your Xbox. It's what takes your input and does something with it. And then the view is how we get the feedback from the system. So on your smartphone, right? On your phone, you've got a couple controllers, right? You've got buttons on the side. Now this is obviously not focusing, but you got buttons on the side. That's part of your controller. But you've also got this giant touchscreen, right? That's part of your controller. The model is the CPU inside. It's the whole inner part of the phone, right? But then your view is also the touch screen. It's the same thing here. This is how it shows you feedback or the vibration inside, that kind of stuff. So model is the GPU of a gaming laptop. No. It's the GPU. It's a CPU. It's the SSD. It's everything internally. On a gaming laptop, the view is the screen of the laptop. The controller is going to be your mouse and your keyboard. And then the model is anything that takes mouse and keyboard input and turns it into whatever you see on the screen. So like the GPU, the CPU, the RAM, the SSD, right? All that kind of stuff, that's all the model of your gaming laptop. If you were to turn your gaming laptop into model view controller. So let's go back to this now. So in this diagram, we're showing the model and view controller of a simple... Yeah, I believe this came about from when we did the MMO stuff a couple semesters back. We have a web and a desktop front end, which are our view. That's how we see things happening, right? They also happen to be our controller. So we can input things through our front end, and we'll also get feedback through our front end. So this right here, both our view and our controller. Everything to the right of this point is our model. So this is what takes our input, which is this arrow here. So it takes our input here, does stuff with it, and it returns it. Blitzkrieg, that's totally fine on the no gaming, like, just, I was trying to give examples as we could. So our front end is going to be our view, and it's going to be our controller. And our socket server, our actor system, our SQL base, that's all going to be our model. So if you think in the front end, back end kind of stuff, very often in programming, your front end is going to be your view and controller. Your back end is going to be your model. Did we go over recursion? We went over recursion last week, and I think a little the week before that as well. So if you want to go over recursion, we're going to talk about that. Can we talk about what WebSocket is? I'm glad you asked. We're getting into that. And I think by getting into that, I think I mean our next slide has the beautiful video that Leo knows about. Yes, it does.
What are WebSockets?
Okay.
Coding for beginners.
This guy explains WebSockets 100% in one video. Okay? We'll talk about actors after WebSockets. Please tell me if it's too quiet.
WebSockets are another protocol, similar to HTTP, but under the hood behind.
Sorry, gonna pause there. HTTP, when he talks about HTTP, that's your GET and your POST request that you guys did in 1.15. Yeah, we're in spring. I can reference 1.15. That's like GET, and then you get some stuff back, or POST, and then you'll post some stuff. Can hear, that's good.
Can or can't?
Can or can't, and is it too quiet? It very well might be way too quiet.
I was thinking it might be.
It's quiet? Yeah, okay. We're gonna start this again.
WebSockets are another protocol, similar to HTTP, but under the hood, behind the scenes inside of your web browser. You might have never seen a URL in your browser's location bar that starts with ws://, but underneath the hood, your favorite applications like Gmail, Twitter, or Slack are using WebSockets. The typical HTTP request response cycle is roughly 1. A user types in a URL to the bar, 2. The browser sends a request to the server, and 3. The server sends some data back to the browser. This ask for something, get something back kind of system works for a huge variety of things, like checking the news or getting your weather. If you want to get more real time though, things that you want immediately, like chatting, your email, or Twitter, then that system doesn't really work very well. You'd have to constantly have your browser say, hey, is there anything else? Hey, is there anything else? Hey, is there anything else? All the time. WebSockets' purpose is to allow a persistent connection between your browser and the backend server. It's like a telephone call where neither side ever has to hang up, and another call doesn't have to be made if new information comes in minutes or seconds later. If the server has information for the browser, it can just send it. It doesn't have to wait for the browser to call back and ask, anything else? A developer using this system can create a front-end and back-end combination system that can receive new data very quickly and responsively show you that data. It's as if it was a stream of information constantly flowing into your browser. As such, WebSockets are the foundation for most real-time web applications.
I thought Jesse said that Socket.io is what keeps the connection up, not the WebSockets. Socket.io is Scala's version of WebSockets. It's Scala's library for WebSockets. So hopefully that made sense to you. Let's start there. So WebSockets are really cool. This guy has explained it. Obviously, I'm pretty sure out of these 24,000 views, I'd honestly be willing to say that like 4,000 are from CSE students over the last like 2 years of us showing this video. So basically, if you think about it this way, WebSockets are like having, I don't know, how do I want to describe this in terms of cabling? Well, let's talk about it like a phone, right? If I have information for Leo, right, I'm going to call Leo, right, and say, hey, I've got some information for you. And Leo will pick up the phone and he'll go, yo, what's the information, right? But if I have information 2 seconds later, I need to call Leo again and go like, yo, I have some more information. That's going to get really annoying doing that constantly. So I could just call Leo once and leave the call open, and then when I need something, I just pick up the phone and say, yo, Leo, I have something for you. There's no need to call over and over again. There's no need to request and post request over and over again, especially because the server doesn't know that it has any new information. The server knows it has information, but it can't get to the client the same way. It's kind of confusing. But the most important part is the difference between get and post request and WebSockets. WebSockets is a continuous connection between all of your front ends and your back end. It's always having the connection open. Yes, but if there is new information to be added. No, Blitzkrieg. This is where it's really cool because the connection is always open, and if there's new information, it just gets sent right over this connection. The connection is always open while the browser is open. So if I was to open Twitter right now, that connection would be between me and Twitter while my browser has Twitter open. The connection would stop when I close Twitter. Is there a time when the connection's not open? When you don't have the thing open. So you ready? Watch this. If I open Twitter, my connection's open right now. Well, now it's open, okay? The second I close Twitter, it's done. Is that what the ping and pong does? I have no clue what you mean with the ping and pong.
What did Jesse tell you about the ping and the pong?
Please inform me of the pinging and the ponging. I do not know what the pinging and the ponging means.
I would love to know what the pinging.
I'm kind of curious as well. Let's continue here.
Yes.
Oh, like it tests whether connection is still up. No, it's just. I mean, yeah, the ping. Oh, okay. It's a message that he said is commonly used. Yeah. So it's to send to like say, hey, it's still up. In the actual server part of it, there's a lot more complicated stuff that goes on with it. There's messages constantly being sent back and forth, sometimes with new information, sometimes not with new information. Take 312 for that. Ping and pong will almost definitely not be on the test. Yeah. So let's talk about what a socket server actually looks like. So this is a socket server. This is a very basic socket server. I stole this from Jesse, I think. I don't remember. It's been a lot of semesters since. It looks confusing, I know. We're going to talk about it piece by piece. So, we need listeners. So, in order to... Do we need listeners? No, we talk about this first, and then we'll talk about the listeners.
Yes.
So, there's a couple important things in here. First of all, we have these import statements here. Okay? Which just import a bunch of stuff. We just need stuff to start with, okay? So from Socket.io's listener thing, we're getting the connect listener, data listener, disconnect listener. From Socket.io itself, we're getting the acknowledge request, configuration, the client, and the server. We're getting a ton of stuff, right? Then we're making a class called server. And every server has a configuration on exactly how we want it to exist and how we want it to function. So our configuration is a value named config, which is equal to a new configuration, which sets a host name and a port. Universally, the host name is generally localhost, and the port for web apps is generally 8080 when you're running it locally. You can do 8000. Google the exact ports. There's a ton of them that's just open on your computer, but don't just put a random port in there. That's actually really important. Don't put a random port in there, otherwise you will screw with other stuff on your computer. So, stick with 8080. If you're curious to know if a port's valid and you can use it, Google it. Then you're going to create a new socket server with this config. That's super simple. You guys have been creating new objects for like 4 weeks now. What happens if it isn't valid? So if you create a server on a port that's not valid, I think it overrides whatever is currently on that port.
Pretty sure you're
right. So if I remember correctly, I know that Discord uses 25565 to communicate. Something I might be wrong on that port. But if you start on 25565, let's say that's what Discord communicates, Discord won't be able to communicate until you turn it off. So just suggest to stay on the ports that are valid. The ones I know off the top of my head are 8000 is valid, 8080 is valid, and 8081 I believe is valid. I'd stick to those three. There's no reason you should ever go off of 8080, but if you were curious, there you go. So you make a new socket server. You can stop Discord's communication on your PC for a time.
Yes.
While it's off. Like very specifically those circumstances. I'm gonna turn my exposure down a little bit.
You can't just stop everybody's Discord.
You can't just kill Discord. Do they not give me the pointer? Yes, the laser pointer. Okay. So we have a new Socket.io server that takes in a configuration here, which we just made here. Okay. So now we have this server, which is a Socket.io server. does the ports only apply to you? Yeah, they only apply on your computer here. Whenever we create something on localhost, it's only going to be able to be accessed on your computer. It won't be able to access on anyone else's computer. So now we need some listeners. So listeners are basically, in order for us to be able to listen for specific messages from the socket server, we have to create listeners. So here we have a connection listener. So we're listening. Our server is waiting for somebody to connect, and this is what they're going to do when somebody connects. Which is just create a new connection listener, and we'll go into what this is. We add a disconnect listener, which is what's going to happen when somebody disconnects. And then we have these event listeners, which is what's going to happen when one of these event name happens. One of these things of this event name happens. So when a thing of stop message happens, something here is going to happen. And when an event of stop server happens, something here is going to happen. And then we just tell the server to start. We're gonna get going. We're gonna start doing stuff. So, as I just said, listeners, in order for us to listen for specific messages on the socket server, we have to create specific listeners for those. So some examples are users connecting or users disconnected in a chat client that the message sends. What does the Val server, I assume you mean what does the Val server do? And that's this Val server is going to be what our server is. There's a class called socket.io server that we've imported. We're creating a new instantiation of the class and doing a bunch of stuff to that class. So let's talk about these listeners that we made. So if you look back here, when we said add connect listener, we actually add a new connection listener, and disconnect listener, we add a new disconnection listener. And this is what is going to go on. Make it stop dying while talking. This is what's going to go on when we connect. So when we connect, we're creating a new connection listener, which right now, all it's going to do is it's going to run this onConnect method, which is just going to print the line that says connected with the client. It was a cough, not a sneeze, but I'll take it. Same with the disconnect listener. We have a class called disconnection listener, and on a disconnect, on a client's disconnect, we're going to print disconnected and the client ID, the socket ID. Super simple for right now. Okay. Then we have these other two listeners. So if we go back here, we had added these event listeners, right? So we said when we get an event name of chat message, which has some data of class of string, we're going to say that we're going to make a new message listener. Same with event listener. When we have a new event of stop server with no data, we're going to make a new stop listener with a parameter of this, as in the server. So our message listener here extends a data listener. So it's listening for data coming through. And on data receiving of the message listener, we're going to print the line that we received the message of this data from this socket. And when we receive the stop server request, we're going to on data, so on us receiving something, obviously no data in this case, but on us receiving the message stop server, we're going to print the line stopping server, we're going to stop the server, and then we're going to print the line it's safe to stop your programs because we've stopped the server. So we're going to make a socket server now. Is socket our system at this case? I'm not sure what you mean. We're gonna rephrase that question. I'm going to keep going. I'll come back to your question because I'm not super sure what you mean. We're going to make a socket server as a group. Now, obviously, as I've gone through a trillion times, this works better when we're in person and we can kind of walk around and help you guys with that kind of stuff. But you guys, if you have IntelliJ open, great. We're going to do this together. And by together, I mean I'm going to let you guys do this for a couple minutes while I get some water. And Leo will be here to answer questions in chat. If you don't have IntelliJ open, grab a piece of paper and do some stuff. We're gonna do a couple things in here. So we're gonna make a socket server. This is gonna implement a lot of stuff. This is gonna do some object-oriented programming in here, and this is gonna do some, concurrency in here. We're gonna make Twitter, kind of, not really, but kind of.
In a way.
So we need a couple things for Twitter, right? We need a class for tweet, so that way we can categorize things as tweets. We need listeners, right, for on data for receiving a tweet. We need the socket server itself. But first we have to have some imports. So I stole the imports from Jesse. These are the same ones that we used before, right? So our connect listener, our data listener, our disconnect listener, that stuff. Okay, so this is our class tweet. Is socket our system at this point? Like socket : socket. I still don't know what you mean. I'm not sure what you mean. So keep going on the trying to rephrase your question. So everyone, if you can, take a couple minutes right now. We're going to make a class called tweet. It's going to do these things. So it needs to have a tweet in it, and the string must be under 180 characters, and that variable of tweet should only be assigned if the below method is true, and that method is checking to see if the string is under 180 characters and also non-zero. If it doesn't meet those expectations, it should return an error message, and just like an error message put in that string. We need a username variable and a like counter with a method to be able to iterate that the amount of likes. All right. I'm gonna grab some water. I'm gonna throw the music back on too.
Go grab some water.
Oh wait, hold on!
Oh my gosh!
Hold on. This is way more fun. Hold on. My favorite time comes. Leo knows what's going to happen. We have banned the person, therefore we have the ban hammer.
We have the ban hammer.
I've been waiting all semester to use it. I've been waiting so long to use the ban hammer. For those who don't understand, a bot came in, and so I immediately banned the bot because they do stupid things. So now we throw the ban hammer.
And we threw the ban hammer on them.
Basically,
the bot came in here and said, hey, you want followers? Come buy followers. And it's a scam.
So we said no.
We said no, we don't want followers. We have enough. And we threw the ban hammer on them.
Alright, so I'm going to move back to the desktop here. Alright, so we're going to... What's a bot? It's a Twitch... It's a program that somebody has on that basically connects to random Twitch channels and sends messages. This one is wanting to buy followers and Twitch Prime subs and views and that kind of stuff to make your stream bigger or whatever. I don't know. This is what the class tweet should have. I have an example of what this class should be on the next slide. We'll talk about it in a couple minutes. We don't care about retweets right now because just honestly, we don't. I mean, if you want to implement retweets, it's the same as implementing the likes.
Logan, go back and get your water already.
My water.
Get out of here. We don't want you. We don't want you. Bye, Logan. Everybody say bye, Logan. You know, we could all play a prank on Logan right now. When he comes back, we could literally tell him, "Hey, your room looks like garbage," or I don't know, man. Give me some ideas for pranks, guys. Let's play a prank on Logan. What should we do? Oh, everyone just go silent. I'm okay with that. I'm actually okay with that. No, because I need him to keep his office hours. I don't think he's gonna notice I don't think he's gonna take away his office hours because we decided to prank him a bit. I think I could delete your message. Ugh, I'm not in mod view. Hold up. Okay. I'm pretty sure I can delete your message now. Oop, I cannot. I thought about saying something, but I don't know if it would be okay. It would probably not be okay. Maybe. It might not be okay. Depending on what it is, it might not be okay. Most of the time, if you think that is not a good idea. Most of the time, you think that's not a good idea. It's not a good idea. Yeah, it
So
usually isn't a good idea.
so here's the important stuff that I've learned from my trip.
Yes.
You forgot that I have a wireless headset, and you can delete messages doing. I
I
think
could.
it's.
we've been caught, guys. Everybody scram! Everybody scram!
Yeah, no, it's way more work to take my headset off when I go downstairs than it is to just like leave it on. Also, it's really bright. What the fuck?
Quick question: is taking 220 and 225 together hard? I'm assuming you mean 250. I will answer that at the end of this if
Yeah.
there are no further questions. So stick around, and I will answer that because I am currently taking 220 and 250 together right now.
All right. How many of you have actually written the tweet class?
Yeah, I told you guys to write. Come on, I told you guys to write the tweet class. Come on now.
Totally didn't ask to come up with pranks.
Yeah.
On paper is fine.
On paper is
fine. If
good.
you were writing pseudocode on paper, totally fine.
Mission failed. We'll get them next time. Yep. Maybe next time.
I don't know if they're upping the on paper or on the mission failed. I assume the mission failed, but
No, they're upping on the mission failed. 100%. It is fine though.
I have not written it down, but mentally I wrote it in my brain. All right, well, that's the best I'm going to get from everyone. Then let's go. So this is the tweet class that I made. It takes a string, which is a string. It takes a username, which is a string, and it takes L, which is our like variable. Well, our incoming likes. I don't remember if I didn't say the need to take any parameters, but I made it take parameters. I made this check string method, which takes a string, returns a string, and it says if the length is less than 180 and the string is empty, we're good. Just return that same string. Otherwise, we're going to return the string, this tweet is over 180 characters / invalid tweet. Our var tweet is going to be a string, which is equal to check string of string. Our username is just going to be equal to user. Our likes are going to be equal to L. And our method liked is going to just increment likes. Blitzkrieg, where are we off on?
Exactly. Specifically, where were you off on? Which line?
I'm not talking which line. I'm just like in general. Because like, yeah.
I guess we'll never know.
I guess we will literally never know what line he was off. The check string. Okay, well that is the one, like, not the one, but that's like the difficult one.
We'll say it's the complex one.
You could do it in a couple different ways. There's definitely a couple different ways you can do it. This is the way I chose to do it. But like, there's probably other ways you can do it in like one line and stuff.
Most likely.
All right, so let's talk about listeners now. So on your socket server, let's pop back here. Yeah, we made these listeners. This connection listener, this disconnection listener. We had the message listener. We had the stop listener. We had a couple different listeners, right? We're going to make some listeners now. We're going to make a connection listener. Take the one from before. I really don't care. Disconnection listener, which take the one from before. I really don't care. And a tweet listener. So when we have on data, I'm going to pop back to the other listener while we do this. Take notes on this right now so that we can see it. On data should take a tweet and it should print that tweet. Extends data listener of something. I'm not going to give you guys a huge amount. I'm going to leave this up for right now because this should help you.
In a way. No, it definitely should help you.
I was going to say, what do you mean in a way?
No, this definitely should help you. Also, class message listener class. We didn't make class mess. Oh, wait, no, it's a template. It's a template. It's a template. Follow the template. Follow the template, everybody. I don't know what I was talking about. We're not going to give you the answer. Sorry. It's not how it works around here. Yes, feel free to make the classes yourself. forgot. We have to make you guys do work. That's what they did to me last.
This
semester
is a very interactive lab here, and by lab I mean review session.
I forgot you made me do this much work. I remember.
Also, I'm gonna turn the music back on.
Music back on. Oof, 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 oof. I'm at a rate.
You can now hear the music too, which makes it even funnier.
Yeah, before I couldn't hear the music, guys. Actually, no. You know how I could hear the music though? I went on the stream and just turned up the volume.
Yeah, but then you had to hear yourself too.
Yeah, it's okay. Happens. Yeah, Logan apparently has some of the music that just turns you up.
Always. Do we want to change it up today for the rest of this review session?
No, it's okay.
Change it up.
Okay. Okay. Let us know when you guys have completed the tweet listener, or have either mentally or physically on paper completed the tweet listener, right?
Yeah.
On paper. Okay. Is it me or is Leo's camera reversed this weekend? This week? I'm pretty sure it's reversed.
It's reversed comparatively to what it normally is, but this is how it actually is, right?
Yeah. Well, I think on my OBS settings I have it as reversed.
Well, because it probably reverses it automatically.
Yeah.
You're stuck mentally, not gonna lie, with the tweet listener. Okay. Let's talk about this. I'm gonna pull it up. We're gonna talk about it. Okay. So this is our connection listener, our disconnection listener, and our tweet listener. Our tweet listener extends data listener of type tweet. We have an override with an on data that takes data is a tweet, return to unit, print line, data.tweet. I'm ready for the to come in on chat.
Oh, we just print it? Yes, we just print it.
Also, we're totally going to switch playlists now, by the way.
Okay. Whatever you want. What the Socket.io client?
What's the Socket.io client?
Oh, what is it? Okay.
Oh, it takes it's it's the client's socket ID basically.
Yes. This technically ties into concurrency and actors.
Yeah. So we're doing WebSockets right now. We're going to do actors next.
Mm-hmm.
Yeah. I'm confused. What's the .tweet command? Well,
I'm glad you asked.
Wait, hold on. I went the wrong way.
If Logan could not mess it up, I would be glad you asked.
Because tweet is a variable in the tweet class. You can do whatever the whatever an object of type tweet, you can do .tweet. You can also do .username, .likes, .liked as a method, .checkString as a method.
So let's go back to the tweet listener, Logan. So data in this case, if you look at it, when you're defining on data, is an object of type tweet, which is why we can say data.tweet or data.likes, because we're just accessing the variables inside of the tweet class from data.
How is it going to continually check if the string is greater than 180? When you create a new tweet, it checks the string when it assigns it. This is not the most fleshed out idea known to humankind, by the way. This is a very quick and dirty 10 minutes before review session 2 years ago thought of idea kind of vibe. So there are definitely holes in here, and this is definitely not exactly how Twitter works. Otherwise, my name would be Jack Dorsey, and I'd be a millionaire. Well, billionaire.
Well,
I don't know. Is Jack Dorsey a millionaire, or is he a billionaire? Regardless, doesn't matter. He's really rich. That's the important part. He's also got an incredibly long beard. I don't know if you've seen pictures of the man, Leo. He's got a really long beard.
I'm looking up. I'm looking it up
Okay.
right now. He went public in November 2013, and within hours, Dorsey was a billionaire.
Okay, so he's a billionaire.
So in 2014, Forbes pegged him at 2.2 billion.
Okay, so that means he's worth like $1 trillion now. Okay, got it.
No.
Joking, it's not that much, but
So as of March of this year, he's worth roughly 5.1 billion.
5.1 billion. Okay, that's
Yeah.
actually not as much as I thought. Okay, but let's talk about now the actual server. So we made this all the way at the beginning. We made one of these. You need a config. You need a new server. You need to add your connection listener. You need to add your disconnect listener. You need to add your event listeners for tweet listeners, right? Which listens for messages of new tweet with tweet data. And then you need to start your server. I'm going to give you like 3 minutes to do this. I'm going to leave this up for another 6 seconds here. Actually, I'm going to write in chat. Or messages. Wait, what am I doing? I'm just go back. I'm gonna copy paste because I'm lazy. I'm copy pasting the new tweet listener part because it's the only super different thing, and I'm gonna pull up the original server that we were looking at before. So basically, make this, but add a tweet listener, and don't have a like chat message or a stop server listener. This should not take very long. This should be kind of simple from this point on. Just use what we currently have on the screen as a template.
I would hope all of you are doing it, by the way.
And if you're not,
and not doing it mentally.
and if
and
you
if you're-
are doing it mentally, make sure to come back to this review session to do it actually, because this is
Yeah.
good practice to do.
And if you just decide not to do it at all, Logan will drop the ban hammer.
No, I'm just
no,
gonna
he won't.
cancel office hours for you.
Yeah. They get. I noticed in chat they get pretty worried when you about you canceling your office hours. What's the deal with that?
I canceled them on Monday because I was dying.
Oh, I see. That makes sense. No, that makes perfect sense now that you say that.
Bro, COVID shot hit me hard.
It hits. I'm pretty sure it'll hit most people hard.
It didn't hit my mom got it at the same time as me. It didn't hit her at all. My dad got it like the next day. It didn't hit her at all. I got Pfizer. My mom got Pfizer. My dad got Moderna. Neither of my parents got hit. I got hit for like 2-3 days.
Did any of you have COVID prior before or no?
Mm-mm.
Never.
Nope. And
What
it was
they've
all
been-
second shot. First shot didn't affect me.
What I've been hearing is that if the people who have had COVID prior are the ones who are getting the worst symptoms.
Nope. I've
Interesting.
left my house in a year.
Left my house in a year.
You think I'm joking? I'm not. Like somebody's delivered our groceries every week. Like I haven't left my house in a year.
Really?
Yeah. I know my immune system's kind of shitty though, so
Cursed New York
Yeah.
State when my whole family got COVID and I was the only one and I had to fend for myself.
all right, let's go talk about this this server now. It's the actual last thing in this presentation. So this is all it was. It's basically the same. I took out the import statements because those were kind of useless for this. We already talked about them.
Yeah.
Make a new server with the config that we made. New connection listener, new disconnection listener. We have an event listener that is a new tweet. It takes data of a class of tweet, and it has a new tweet listener. Now, above board, this will not work. We found
Not
this out
completely.
2 semesters ago. This will not work because your front end doesn't know what a tweet is. So this kind of has to be of a string, but I wanted to include object-oriented programming in here. This should be a data type in here, the class of this. This should be a data type that is native to Scala. It shouldn't be an object or class that you make. But I wanted to put it in here to get a little bit of review in here as well.
Basically, try not to pass objects of types that you guys make or
Yeah.
classes that you guys make. Just
Yeah.
use the regular data types.
Yeah.
That's all it is.
That's going to be it for WebSockets. Does anybody have any questions on WebSockets before we
Move on
switch
to
gears and move to actors?
actors. I'm acting. Acting. Can I act like I don't know. What should I act like?
I think you
I'm
should
a-
act like Leo.
I do that. I do that every day. As soon as I wake up, put on my Leo face. Go to attend UB like Leo. So that's what you did. That I'm glad. I'm glad that's what you did.
No. This is right because this is what I told you guys to do. What I'm saying is, if you were to actually like use this, it wouldn't recognize that there's a data of class of tweet incoming because it doesn't know what a tweet is. So you'd have to have it as a string. It would actually probably be multiple strings, probably a list of strings, to be honest.
Yeah.
Don't super worry about that part. Worry about all the parts in here that you understand.
Just worry about the fact that you made the server, how
Yeah.
it should run.
You just, instead of sending a tweet, you send it a string. I
Yep.
wanted to throw some object-oriented programming reviewing in here as well, so
Yeah.
that happened.
Logan and the person who also made this back then were not thinking. But it's okay.
Can we go over how strings are stored in memory?
That
Yes. If it's a
Yes.
string, it's stored on the stack until you get to 220, where it's not.
wait, what? No, strings are stored in a heap.
No, they're stored on the stack.
Even 116 they're stored in a heap.
No,
I'm
then we say they're stored on the stack?
I can't Scala data types.
No, they're actually stored in this heap, yes. Because their list of... They aren't stored on the stack? Jesse said they're not stored on the stack. Okay, that's fine. They're stored on the heap. Okay, they're stored on the heap. For
Yes,
like
they're
2
stored on the heap.
semesters... For 2 semesters, we were saying that they were on the stack. And I was
Yeah.
like... We had to like... Yeah, they're referenced on
They
the stack to a
referenced on the
place in the heap. Because they are technically a list of characters.
Logan, don't mess the people up, all right?
Okay, Leo, for semesters we have said that strings are stored on the stack,
I
and
don't-
then
I
we
don't-
just decided to switch
I don't
it.
know,
So
man. I don't know, man. You guys told me it was stored on the heap last semester.
yeah, we purposely told people they were stored on the heap. We were making sure that like people knew the real things.
Well, yes. To answer your guys' questions, the string is string is stored on the
I'm
heap.
so lost can vouch for me.
I trust me, I don't think you can vouch for him.
No, I know who that is. They could vouch for me.
Looks like someone has some studying to do. Yes, he has some massive studying to do. Imagine Jesse lurks around in this stream. He actually does.
Yeah,
Sometimes he'll come in.
Jesse has been known to lurk around.
Yeah.
All right, let's go talk about actors. I put us okay. Let me go back to here.
We are moving on to actors.
Yeah, nobody had any questions. We had an entire discussion on other stuff. How they look on the heap, they look like a list of characters.
Yeah. It just kind of looks like a list with like different characters. So if you had
You
hello,
have a character on each line.
yeah, it would literally just be like hello H, comma E, comma L, comma L.
Well, no, it'd be like H in one thing, and then E in the next thing. And
well,
then, like...
yes. They look like ones and zeros. No, do
God
not.
damn it!
That's not.
Can I? I'm gonna ban Chewy Skittles. I know who it is, so I feel confident in banning him.
I know who it is.
Well, he's not a student right now. Throwing the ban hammer in. Yo, this class used to be set up super weird. I'm trying to find the.
I can tell.
No, because it used to be concurrency was before data structures,
I know.
and then it wasn't, and now it is again. Give
no,
me
it's
a
not been
moment.
twice today. We actually know who Chewy is.
Bye, Chewy. See you later.
Bye. Nice to see ya.
I mean, that's not how I'd spell hello, but like, yeah.
I mean, yeah.
That's how I would spell hello, but like, yeah. I mean, you
LD.
could just put it together in one thing. As long as you show that the string appears on the heap and not on the stack, you're fine.
Yeah. Just mention that the string gets put on the heap and you'll be fine. You can just put it as hello.
Like, if you write on the stacks var x is a string. It's found at heap 234, and then you put in your heap at 234, and then just write the string. That's fine.
I'm telling them what to do as if I'm the TA for their class. Sorry, guys. I'm not your TA.
That's spelling, man. That's not grammar. Okay, where is like the stuff I'm looking for?
Okay, you're looking for actors. Find the actors.
I'm looking for the folder for fall 2021, and that doesn't exist because we haven't had fall 2021 yet.
Go into fall 2020.
It's not here, man. This is Gen Algo. Right?
That day, 10 days before the big spook.
Yeah, this is Jacob's Gen Algo.
Yeah.
Right? This is Stack and Heap.
Yeah.
Okay. And you'd think it would be in fall 2019 when we started doing these. It would be in review slides, but there's none in here. This is not that. It could be this one, but this is just a giant video of them. This is WebSockets. It would be the one before or after this, which none of them exist in here. Hold up, let me just look in my Google Drive.
I'm gonna stay up all night and grind PA. Do not do that. Start it early. Well, actually, it's too late to start early. So try your best. Try your best to start as early as you can.
That's the wrong one.
I'm so confused on actors, and that is why we are looking for these actor slides. Clearly, Logan is having a hard time with that.
I don't know if I have slides. I just assume I have slides, but like...
I do not believe you have slides, and if not, we can go to Jesse's.
I mean, that's kind of generally what we do. Okay, I don't have slides.
Can we go over
these are my
AO...
WebSocket slides.
Can we go over AO1?
No.
No.
I don't know how many times okay, you might be new to the review session. If you're new to the review session, we don't go over specific homeworks here. We go over concepts. CSE 116.gov.
We go over concepts, and if nobody has any questions, everybody just asks, just pings Leo and says, "Hey, Leo, how's 220-250? How's 220-250?"
Basically, yeah.
Okay, can you go over AO1 concept? No.
Still no.
I already know the
also
answer.
No. Also no. The answer is no. All right. I tried to grind the GA daily, but got tried back by the cuss. I feel that.
Yeah, it happens. I had the same thing happen to me last semester. It's okay. Try your best.
Oh, what? Yo, this is the most get out of jail free card I've ever seen, Leo.
My gosh. That's crazy.
That's insane, man.
He gave it to them.
Oh.
He gave it to you guys.
Oh my god. So that way everyone knows what we're talking about. What's this? What's this? What's this? You'll not be required to write code using concurrency. So we just did that whole thing. But you should know how to explain the concepts of concurrency and WebSockets now. We'll talk a little bit more about concurrency in a minute. So
we will no longer make you guys write code.
We will no longer make you guys write code because we didn't know you didn't have to write code. Okay, so concurrency is really cool. Basically, normally, okay, things happen in order, right? When you... Oh, you need to trace their actor code for the quiz? Okay, good. Then I'm very happy I forced you guys to look at WebSocket code.
Yes.
Okay, so basically, here's the thing, right? Normally, when you write a program, you have a main function, right? And it executes in the main, just like boom, 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 right? That's what it does. It just goes through, and that's it. Concurrency says, I'm going to do many things at the same time. It's kind of intense. It's kind of weird to think about.
Like literally at the same time. Like literally, like you look at your watch, 1 minute, boom, both things happen at the same time.
You'll get into 341 and learn that's actually not true, but yeah.
Yeah, you'll end up learning that that's never true.
But yeah, okay. So what if we want to execute multiple pieces at the same time? So what if multiple people want information? That's when we use actors. Okay, so in 115 you wrote a web server. And if two people were visiting, the server waits for requests, handles them in the order as they're received, and they go back. You provide callback functions that are called when a request arrives. Super simple. Super normal AJAX server. 116, we've seen GUIs, which run update loops to keep the current state of the software. So when you guys had in either microwave or calculator or point of sale, which all had this, you had the display string, right? Which you just had to put a string in there. Your code will constantly call display string. The GUI will constantly call display string, continuously updating it anytime you change what the display string is. And you provide listener classes with a method that's called when a user takes an action. So for calculator or point of sale or microwave, I guess that would be number pressed. When you press your number sale, that's a method that's called when your user takes an action. I'm trying to bridge the gap between everything here. So yeah, we want to write concurrent code. We want to write code that gets done at the same time. So we're going to use actors. So actors, when you're talking about Scala, actors are universally used with the Akka library, which is it's already been added to the pom.xml, which I think is in one of the frames below the Twitch stream if you don't have it, which at this point, if you're in week 10 of the class and you don't have the pom.xml or know where to find it, rethink life.
Yeah.
So Akka uses actors for concurrency. So we can make and instantiate actor classes, and each actor will run concurrently with each other. Is Akka the only actor library out there? No, it's the one that we use for this class, and it's the most ubiquitous one. So it's the one that if you're using Scala and you're using actors, you're using Akka. It's the only one people care about.
It's also very easy.
It's also super easy once you figure it out. So actors are based on a message passing system. Multiple actors run in the same program at the same time. If you can pass messages to and from actors to share information, and you can write code that executes in reaction to a message. So if I tell Leo you're dumb, Leo will have a reaction to that message. I expect you to say something to that, but apparently Leo's
I will
reaction...
not. I will not say anything.
Okay, I don't know if that helps my case or not.
My reaction is a yawn.
So the messages are case classes or case objects, which are just like giant if statements, right? So receiving a message is an event. So if I tell Leo you're dumb, that's an event. Leo hearing the message you're dumb is an event. Which brings us to what this is called. It's called event-based architecture. We write code that only gets executed when something happens. And we're going to make stuff that happens that's going to force code to run. So Leo will only, yawn when I say, you're dumb. That's the only time that gets executed in Leo's mind. I like how we're turning Leo into a computer here. I'm very sorry, Leo.
I'm already
I'm like medium sorry, actually.
You should not be sorry at all.
Medium sorry. So a case class is primarily it's a new type of class in Scala for all of you. It's a very old type of class for me.
Yeah.
It's used to store values provided through the constructor. They don't have a body. They're compared by value, not by reference. And we have a case object, which is being used when there's no values that are being stored. But either of them can be used to signal that an event has occurred. So, I know that didn't make a huge amount of sense in the case stuff, but we're going to go into it here with actors. So, we're going to import the actor class. We have a case object custom message type. We have a case class, another message type that has some data on it. Concurrency is just writing code so that whatever we have can run concurrently without having to put in wait queues. I don't think you can use the word in the definition, but yes, I think.
So concurrency is just running code so whatever we want. We can run concurrently without having to put in wait queues. Sort of.
Again, using the word in its definition is kind of hampering this definition here.
Yeah.
Okay, let's talk about this for a second. We have an actor that extends the actor class. it has a method called receive, which receives something. And in here, we're saying, if you receive the message, custom message type, we're doing something. If you receive received, we're going to do with another message type, we're going to do something else. Basically, if we do this, we're going to do something. If we do this, we're going to do something else. Big if statement.
And you can also think of received as kind of like a variable, and you're kind of saying, hey, this variable is of type another message type. And that's why you can access another message type's message over there.
Yeah.
Because you're basically saying, hey, received is the variable, it's of type another message type,
which has
receive.message.
Which has this value.message. I know that kind of sounds confusing. Okay, so I'm trying to figure out how much of this I just said. So messages are instances of case classes or case objects. Use a case statement to make decisions based on the type of the message. If the message is the case class, declare a variable to access value. So that's what Leo was just saying. We're declaring this variable received, which is of type another message type. If it's that, we're going to receive a message. We're going to do receive.message. This is how you send. So lost right now. Okay, let's back up for a second. Where did I lose you? Because we can lose people very quickly here, and you're probably not the only person that just got lost.
Yeah. Where did we lose you? Which path did you take?
I'm lost at receive. Okay. Priest Pope, we'll get back to your definition of what is concurrency later. Should we start back at receive? I know T-Mirror wants to start back at receive. Blitzkrieg, you want us to start back at receive? So actors act like a forward and backward response.
Like, I don't know how to answer that, only because
yeah,
it can, but not in this case.
Yeah.
Basically, what's happening here in this class, my actor, is we have a receive method, and all this is doing is just getting messages. So
basically,
the messages are going to go here.
Receive gets called when you receive a message.
Yep.
Literally anything. So if I let's define three messages right now. Let's say one message is hello, one message is I don't know, do your homework, and one message is goodbye. Okay? There's three messages, right? Hello, do your homework, and goodbye. One of our case objects will then be hello. If we receive a message of type hello, we're going to do something for it. If we receive another case object will be goodbye. If we receive a message of goodbye, we're just going to do something because of it. If we receive a message of clean your room, that one's got a little bit more to it, right? It'll have a message. It's do something, right? Clean, and then what? I want to clean my room, okay? We use custom message type doesn't have a received variable because it doesn't have anything with it. It's an object. It doesn't have any more oomph to it, right? Another message type has a message with it that we can access that message of, which is why we make this variable received, which is of type another message type, which means we can access that dot message variable. I'm confused with the purpose of actor class. How does it being used? So we can use our actors in code to represent different users. So we can have an array of different actors. I don't know why. Oh, I know exactly. We can have an array of different actors. And we can say user 1 is actor 1, user 2 is actor 2, user 3 is actor 3, user 4 is actor 4. We can do different things based on each user, based on each actor. I don't know if I further confused you or less than confused you.
So, Logan, can you draw on the slides?
I can.
So, think about it like this. You have two actors, and we have actor 1 and actor 2, or user 1 and user 2. And you could draw that. U1 and U2. And let's say user 1 wants to send a message to U2. So user 1 will say, hey, I want to send hello to U2. U2 will then receive that message.
I don't know how to draw receive. So...
It's fine. But just understand that U2 will receive that message and will say, hey, this is a custom message type. Let's do something with it. That's like a good way to think about it, and what the purpose of the actor class is.
Is concurrency actors in action? Yes.
Yeah.
But basically. That's not a good definition of concurrency.
Yeah. A good so I would... What your definition for concurrency was, you said can run concurrently. I would change concurrently with simultaneously.
Yeah. It's multiple... Concurrency is multiple pieces of code running simultaneously. So actors are built on users' needs. I mean, isn't all code built on users' needs?
Technically, in a way, yes. All code is practically built on users' needs.
I think so. Let's keep going and we'll come back if we need to. So this is whoever... How do we know if the message is custom message type of another message or another message type? You don't need to know. That's the beautiful thing. This receive message figures it out.
Yep.
This receive message says, if it is custom message type, do this. If it's another message type, do this.
And that...
How does the computer know? The Akka library.
Yep.
There's no better answer to that. It's the Akka library. If you want to go figure it out, go through the Akka library.
Also, user 1 might need to specify sometimes.
Yeah, when you send a message, how does Akka know? Okay, A, you don't need to know it for anything we're testing you on. B, honestly, I don't know off the top of my head. And C, let's go back to the first thing. You don't need to know it.
Yeah, you really don't need to You don't really need to understand why or how do they know that it's that. You can just say, yeah, we know it's that.
Correct.
And usually user 1 will, if it's a user sending to another user, user 1 will usually specify what it is.
Correct. So messages are an instance of a case class or a case object, right? Here we talked about messages, right? So you can use a case statement. So a case class, right? This case statement, you can make a decision based on the type of the message. It's these right here. We make different decisions for custom message type and another message type based on the type of decisions. We usually don't know what will start or end first. I don't know what you mean by that, pre-spoke. So if you have a case class, right? If your message is a case class, so another message type is a case class, we declare a variable, like received, to access the stuff inside of it, because that means that with this method, with this message, it's carrying some form of data payload. And we want to access the payload. When the code runs, so concurrent code will still run in a linear order. But there will be a point in which it will be able to run things simultaneously.
Yes, true. When the code runs and you start all the code at once, you can't determine which will end first. That is true. You can't always determine which will end first.
Correct. So now you can create an actor, add it to an actor system. So we say val actor is part of the system, which is an actor system. It's an actor of props of class of my actor. But can we determine which will start first? No.
No, so we don't have any choice as to what starts first and what will end first.
They'll
we can just start them simultaneously. That's all it is.
So we thought of it as a tree, like one thing runs it and it branches up to two pieces of code simultaneously. It could be multiple pieces of code. It could be one piece of code. It could be two pieces of code. It could be 700 pieces of code. So now, using this app method, using this object, we can send different message types to the actor. We send it using the exclamation mark. So we're sending here to the actor custom message type. And here we're sending actor exclamation mark another message type. Also, I'm super not vibing with this, so we're
Yeah,
switching
this is
music.
not. I don't know what you were thinking with this one.
I don't know. We switched back. I'm switching back, man.
Yeah, thank you, thank you. That made me feel like I was in like the Vikings time.
We can send messages to our actors with this exclamation mark. What's actor of props class if my actor? It's basically you're saying system, you're creating an actor of props, which is a part of the actor system. Class of, we're creating an actor of the class of my actor, which is what we made up here. My actor.
I would
Basically,
also say
TLDR, you're making a new actor. This is
Yeah.
just how you make them.
I would also say don't look too much into that. Just understand that we're creating a new actor and putting it into the system, and that's
Yeah.
all it is.
Yep, that is 100% it. And we're going to send it a custom message type and then another message type. Yeah, here we go. Just goes into it right here. You cannot create an actor using the new keyword. You want to use props and pass the class as part of the argument. Just as Leo just said, you got to understand this is how you just make an actor and add it to the system. You don't make it with new. You do it this way. So I do not need to understand creating new actors for the quiz. Just understand how the code runs. Well, I mean, you should understand that to create a new actor, you don't use new. You use this line of code, but you don't need to understand exactly what this line of code does.
Yeah.
You just know
that like all you'll probably need to understand is just that you're putting a new actor into a system with many other actors, if there are many other actors. That's all it is.
Mm-hmm. So if your actor class takes any constructors, so for example, this one takes a constructor of n, you have to pass them in the prop call. So when you do props, class of my actor, comma, and then whatever your parameters are. So 10 would be n in this case. N would be 10 in this case. Counting example. Thank you, Jesse. This is an important slide.
Jesse always made important slides like that.
Always important slides. Okay. So we're going to create a new actor class that counts down from 20 as fast as it can. We're going to send the start message, which is a case object, and we'll create 3 of these actors, and we'll watch them count down concurrently. We might actually do this live.
Yeah. This seems like something we can do live.
Yes.
Oh, he even provided it for us. Yeah. Thank you, Jesse.
Yeah. Okay, so Leo.
He says my name and
I'm gonna send you these slides.
Yeah.
If you could do me a favor and type this in, I'll send you the IntelliJ link when it opens.
Okay.
I gotta piss, so
yeah.
That's.
You guys will learn that Logan needs to go to the bathroom very often.
This is
very often.
Bro, I've got issues, man. Don't worry about it.
We're not gonna question Logan on his issues.
Don't worry about it. I drink a lot of water, man. This is like bottle number 5 today, so when you hydrate yourself.
Oh yes, Logan is a big water drinker.
Big water drinker. When you hydrate yourself, man.
Very much so.
Leo.
Yeah, send me the link.
There's the link. Tell me when you get in, and I'll switch back to the thing.
I am waiting. I do be waiting. Or actually, hold on. I should probably have done it. I did it in the wrong place. Sorry. Okay.
Nah, it's got nothing with nerves. It's just I hydrate. It's hydration.
Logan stays very hydrated for those of you who want to know.
I don't know who needs to know about my hydration levels, but
so if we have 3 actors, then that means 3 different codes.
Leo, you should be in now.
It's loading in, yeah.
Okay, I'm gonna put a ton of enters, just that way it is basically auto scroll to the bottom.
Yeah, that's fine. Okay.
Okay, so Leo's gonna start typing now. I'll be back. I'm actually. Hold on. Let me.
You're gonna bring your headset in there.
No, I'm gonna turn the font up so that way people can actually see. Really? Really? The font?
Font can't be
Really?
changed.
Oh, here we go. Color scheme font 18. Apply.
All right.
Okay. So
Will
Leo
it do the
will
same
type
thing
here.
for me?
No,
it will
you
not.
don't need to worry about it though.
Okay, that's fine.
Okay. So I'll be back in a second. There's no scrolling. So just be
It's
aware.
fine. It's fine. It's fine. Wait, I just need to make sure. Logan's going to be the absolute death of me. Do-do-do-do. Just want to make sure I'm doing it on the right thing. Okay. There we go. Okay, we'll worry about that error later. I think I know what it is. Okay. And let me just go over here.
Back.
Welcome back. I'm doing the imports because I completely forgot you have to do the imports.
Nice.
Yeah, I forgot the imports. Forgot what it is.
Are they not on that thing?
No, because you
Did I
don't
send
have
you?
the pom.xml.
Do I not? Oh, okay. Let me go download the pom. That's actually really funny.
I panicked.
Let me go download the
panicked.
pom next. Hold on.
Look, why did
We
you
never
okay.
needed it before.
So I forgot to answer the underscore root 3's question. So if we have 3 actors, then that means 3 different codes are running at the same time. Depending on when you sent the messages to those actors, yes, the codes will run simultaneously. Whether they start simultaneously or whether they get to the end simultaneously, that's a whole other different story. That usually is not what will happen. All right, Logan, please get the pom.xml. You put me in the worst position. Okay, let's do this. Actually, I can't even do this. Logan,
I'm doing it right now. I'm working on it, okay?
Yeah.
Can you relax yourself?
That was so slow. You were so slow.
I had to go download the pom XML.
Guys, Logan yelled at me. I don't like it.
Leo, I can yell at you even more.
No, that was awful. That was really bad. I'm confused. Are actors whatever we use the exclamation mark on, or are actors just the code?
Actors are a type.
Actors are a type.
Actors are a concept, a thing, a system in which you can use the exclamation mark on.
Yes. The exclamation mark says that this specific actor is sending a message to somewhere, whether it be another actor or whether it be something else. That's what all the exclamation mark is.
Wait, what happened in this function? What the?
I don't know.
Leo, what did you do?
I didn't do that. I did not do that. I did not do that.
I believe you. I'm just confused.
I did not do that. I have an error, but I don't know why. But that's okay.
Well, at the top, it's we have 13 errors. There's so many errors in this code.
You know, can we just make a class? Wouldn't that be better?
Yeah, you want to make a class? Go for it.
I'm gonna make a
Oh,
class.
this is definitely not a real thing that we made. Oh my god, it doesn't understand so many things.
Okay.
I think it's fine now.
I
Okay.
fixed it. Cause I fixed it.
Okay.
Fixed it.
You've got we're one too many, or
I think I can fix it. Hold up. Hold on. Okay. And then if we do import,
hold up, is this closed here? Yeah. What the hell? Why is this not?
okay.
Oh.
I think I might have fixed it. Except I don't think I did the import right, but that's okay. I will figure it out.
I don't know why it's yelling at us at the end. It's expecting a new line.
Yeah, I don't know what. I don't know what you're talking about. It's fine for me. If you go to the counter class, it's fine for me. Look at the counter class. I did
I'm
everything.
in
there.
the counter class, man.
No, you're in the first object. I made a new one in the file structure. Counter.
Oh. Oh.
Yes.
Oh.
There we go.
Let's think with your brain. All right. So we imported our actor. We now have a class called counter. You didn't get the rest of this stuff though.
Wait, no, it should have gotten everything. I'm not too sure why.
No. There was an object. There's an object as well.
Oh, there is. You're right.
Okay. So now we're good. I swear we exist at points in life.
We should figure out the import though, because the import's not working. We have so many errors. We have 16 errors.
Fixed it.
Oh, fixed.
Fixed it by just importing the entire Aka actor class.
Yep.
Okay. So, for just example, right? This counter class is a type of an actor, right? We're going to count down with the unit, basically. If our n is anything greater than 0, if it's greater than or equal to 0, we're going to subtract 1 from the n. We're going to say whatever the name of this thing is minus n at what time, and then we're going to print when it's done, aka it got to the end. Thanks, Leo. And our receive method is going to say we're going to start this.end is equal to 20. We're going to count down. If we're done, if n is less than or equal to 0, basically this is our thing of like, are we done yet? This is our message. Hey, is it done or is it not done? If it's less than 0, then we're going to say, yeah, we're done. If it's not less than 0, we're going to say we're not done. Let's run this. This is going to break first try, guaranteed, by the way.
I would hope not.
Well, it's code that we wrote, so yeah. Oh, because first object has issues.
We love live coding. First off, let me
Always.
delete this. Okay, no more issues.
Let's just it's also having an issue with this. Wait, why do you have an issue with this now?
I don't know.
I'm so confused with Is there like one too many?
I think I fixed it. No. Did I not? Oh, I know why we.
Let's just do that. No, it says semicolon expected, but no semicolon.
You know what? Okay.
No, it's not that in there. It's just the whole thing. I'm just gonna.
Yeah. Comment on everything.
See, like that's just. That's super weird. Okay.
It's fine. Whatever. You got it, buddy. You got it, buddy.
There we go.
Now let's run it.
And just like that. Just everything in here. Okay, counter. Let's run this again. It's not going to have any problems. That's just a lie. Oh my god, that's why it's had a problem the whole time. There's just been one random... Oh my god, that's actually hilarious.
This is just first world problems. It's
Yep.
okay.
Okay, we fixed it. I fixed it. Yep. Not found. Number sorted.
No, just comment out everything. Just comment out everything. Trust me, just comment out everything. Oh, because I did this.
It's fine. It's fine. I just commented it all out. It's fine.
Yep. Let's do it.
Okay. It's compiled everything. So, we'll see. 2, 20, 1, 20, 19, 19, 19, 19. Now we get to 3 when 1 gets to 6. We don't have any choice in the order which this goes. Then 3 goes down, then 1's going to be finished, then 2's going to go for a good chunk, then 3's going to go for a little while, 3's going to finish, then 2's going to finish. Okay? 2 is the first thing that started. Alright? Like, that's kind of weird, right? Let's run this again. Do we think that we're going to have 2 start, then 1 go for finish first, then 3 finish first, second, and then 2 finish last? Do we think that's going to happen the next time if I run this?
Have a good night, Timur.
Timur.
Yeah.
Let's run this again. Stop and rerun.
Let's try it. Let's see what happens. So 2 finish last. 1 finish first.
It's roughly the same thing in ordering, but it's also just definitely not the same thing in order. Because look at how much more simultaneous they're run this time. So we run it again. You'll see this ordering is going to change again. 2, 1,
same idea.
Pew.
But the ordering of which numbers they counted down from changed.
Correct. Because concurrency, it all happens at the same time. So we're not getting updated quick enough. Our prints are not going quick enough to do it. It's pure random, I'm guessing. Basically, yeah.
Basically, for right now, you will understand that it's random.
So it's all running at the same time. So it prints as it gets, as quick as it gets it. But the printing is not concurrent. The printing has happened based on queue. Well, okay. So Priest-Pope, the 116 answer is it's actually simultaneous. Don't worry about it.
Yeah. You don't need to worry about that.
341 answer is it's complicated.
Yeah, you will get more into that in 341.
The 341 answer is it's complicated.
Somewhat complicated, not completely complicated, but complicated.
Leo, you haven't taken 341.
It's okay. I've seen the workload for it. It's fine.
All right. Is there any more we have to go over with actors? Probably.
We can keep. I don't.
Basically, what Jesse said is all 3 counters go concurrently. We don't have any way in which we know which is going to finish first. Just another example. He explains the example which we just did. Then there's the structure. Okay. All right. Does anyone have any questions about actors now?
Yes. Priest-Pope. I wouldn't say so. I think
331 is harder.
Yeah, 331 is
harder.
331 is a difficult course. Recursive, if possible. So you're talking about you want to go over recursion. We can go over recursion. If anybody has any questions about actors, though, speak up now.
Or forever hold your peace.
Because we would want to answer the questions about actors first. I just wanted to change it.
No, that's fine. I want to make sure this works. Taking 220 and 250 together hard. Yes.
Do you want the good question? Do you want the good answer? If you know how to manage your time, no. So what's the important info about actors for the exam tomorrow? Just understand probably how the code works and how to read the code itself. Quick summary of actors, lol. Basic. You can do that, Logan.
Okay, so basically, actors are the thing that let us run things concurrently. Okay? You create actors by extending the actor class. They have to have a receive method which returns a receive portion. They have different cases inside of them. So if they're sent a message of start in this case, it'll do one thing. If it's sent a message of is done in this case, it'll do a different thing. If it was sent a message of like, I don't know. If it was sent a message of case hello, which obviously I haven't defined, it'll do something else. Great. And we define these cases here with the case object start, is done, done, not done. Okay. We can send messages to these actors by saying the name of the actor, exclamation mark, and then a message. Actors are what let us run code concurrently between different pieces at a given moment. Where are the messages coming from? The messages are coming from wherever. Very often you'll have like, let's say you have a list. Very often you'll have something like this, like var x is a list of actors. This is not how you declare lists.
Logan.
Yes.
Logan, come on.
No, Priest, you can say
concurrently.
You can say concurrently. Just if you're asked what the definition of concurrency is, you shouldn't say the word concurrency inside of it, which concurrently is a type of the word concurrency. If you're asked the definition of concurrency, you shouldn't use the word inside the definition.
Yeah.
That's all we were saying. Brain is melting at this point. Well, good thing this gets recorded so you can watch it again tonight.
And watch as many times as you like.
So basically, very often you'll have a list like this, right? And you'll say for y in x, which is again not how you. It's the
Where's
other
the
way.
parentheses? No, where's the parentheses?
Oh my god, bro! I have not coded Scala in so long; it's not even funny.
Would you like me to do it?
No.
Would you like me to do it?
Doing it. What are you yelling at me at now? Oh.
Because it's the wrong arrow.
Because I was right on the arrow the first time.
You just did not put.
Right? So very often we'll have something like this, right? Where we can concurrently we can send a message to all actors. So if I run this again now, it'll send this start message to all of the actors in list X. So it did the same thing this time. Starts with 1, then 2 went, then 3 went, 3 finished, 1 finished, 2 finished. Okay?
So Smeej, what's the second parameter in props when declaring new actors? The second parameter is the constructor of what the actor takes in. So the class counter takes in a string that is the name, and we're giving each one the name of 1, 2, and 3.
Correct. So that way we can print it correctly. Okay. So I'm going to go through everyone's questions really quick. Quick summary of actors. I just did. Actors are what's allowing us to run code concurrently. Yes. Can we go over actor code again really quickly? We just did. Same here. Website. We'll go over website in a second. Where are the messages coming from? Messages are coming from generally something like this, where you'll send a message to all actors, or you'll have a map, right? So let's say var mappy boy is a map of string. This would never be a string, but I'm not going to write the 3, but etc. Where string actually would be your WebSocket ID. So that way you actually have an actor for every single WebSocket. So when you send a message to the actor, that can actually send a message to that specific WebSocket. It gets complicated, it gets combined. You'll learn about the combination on Friday. Okay. Brain is smelting at this point. that makes sense. Setting parameter and props, we went over that. L3 starts smoothly, then concurrency arrives, and it's weird code I've never seen before. Yeah, welcome to 116. It's code you've never seen before. When the code says system.actors, we're creating a new actor of type counter and passing 1 as the counter's number.
Yes.
As the counter's name, yes.
And as the counter's name, yes.
Yeah, it says the counter's name.
And keep in mind that it's also adding that actor into the system.
Yeah.
So in this case, we have a system of actor system counting system, and it's adding each actor into the system counting system.
Yep. Okay. Let's go over WebSockets again really quickly.
Yes.
Do I still have the WebSocket code up? Haha.
You do
no.
You do not.
No. And before I go rummaging around my Google Drive.
So what specifically about WebSockets? Or do you just want to, should we just go over the whole thing?
Immutability. It is a thing that you can't change.
That's all it is.
It's a variable. It's a value.
It's a value.
It's
a
an unchangeable variable.
Changed. The whole thing. Okay. So we actually talked about that in the beginning. But we can speedrun this.
No, we're gonna speedrun it. We're gonna do the TLDR version, which I'm very good
TLDR.
at. That's a very niche joke. Oprah's favorite programming topic is everyone that connects to a web server gets a WebSocket if you're using WebSockets. I need to turn the switch on my camera up because it got dark. Okay, let's go. Model view controller. We're talking about this in terms of an Xbox. Your controller is your controller. That's how you give input to the system. Your model is what takes your input and turns it into something else. That's your Xbox. Your view is how you see what the system does, or feel, or however. That's your view, right? On your phone, your controller is the buttons on the side of your phone, touchscreen. Okay, your model is the phone guts inside. The view is your screen of your phone. I don't know, your headphone jack if you got one, right? That's your view. That's how you get your output from your phone. We're gonna watch the WebSocket video again because it's super good and also really helpful if you don't understand WebSockets. I'm gonna toss our WebSocket boy in here. So if you want to go watch this WebSocket video again, you can. I'm also gonna bump the volume on the desktop.
WebSockets are another protocol, similar to HTTP, but under the hood, behind the scenes inside of your web browser. You might have never seen a URL in your browser's location bar that starts with ws://, but underneath the hood, your favorite applications like Gmail, Twitter, or Slack are using WebSockets. The typical HTTP request response cycle is roughly 1. A user types in a URL to the bar, 2. The browser sends a request to the server, and 3. The server sends some data back to the browser. This ask for something, get something back kind of system works for a huge variety of things, like checking the news or getting your weather. If you want to get more real time though, things that you want immediately, like chatting, your email, or Twitter, then that system doesn't really work very well. You'd have to constantly have your browser say, hey, is there anything else? Hey, is there anything else? Hey, is there anything else? All the time. WebSockets' purpose is to allow a persistent connection between your browser and the backend server. It's like a telephone call where neither side ever has to hang up, and another call doesn't have to be made if new information comes in minutes or seconds later. If the server has information for the browser, it can just send it. It doesn't have to wait for the browser to call back and ask, anything else? A developer using this system can create a front-end and back-end combination system that can receive new data very quickly and responsively show you that data. It's as if it was a stream of information constantly flowing into your browser. As such, WebSockets are the foundation for most real-time web applications.
Okay. I've showed the video again. The rest of this, which by the way, I'm gonna also put the this slideshow. I've been signed out.
My gosh.
And I'm gonna get no, I didn't get Duo. I was actually about to get really offended if I got dude. I'm gonna throw a link to this presentation for viewing it when I get it together. This won't let you in if you copy the link. But basically, you have a connection listener. You've got different types of listeners, right? You've got this giant server itself, right? You've got different type of listeners, like user connected, disconnected, messages sent, right? And then you've got some other stuff. So we went over making your own socket server here. We went over importing. We went over having this tweet class. We went over making your own listeners. So like the tweet listener, which listens for data of a tweet. We went over making the actual server part, and then we threw the unfortunate part that this doesn't actually work because tweets aren't real data types. But we wanted to go over some other stuff. If you want a more in-depth version of sockets, go to the beginning of review session. I'm actually going to go make that Piazza post right now. Leo, I will give you a share-friendly link.
I will make a Piazza post much later, probably after I finish the stream. I'll make a Piazza post quickly.
I'm actually literally just going to copy paste it so that way you can take the whole thing.
Okay. Does anybody else have any other questions while Logan makes this Piazza post? Can y'all slide us real quick the quiz and interview questions? No, and I personally cannot because I have no idea what they are. I am not part of that section of 116. Hopefully I get this in the bag tomorrow. You will do fine because you came to a review session. Is taking 331 and 341 together a good idea or a bad idea? I do not know. I will be taking it together next semester. You should try to take them together because as soon as you finish those two courses, you open the door to many other different courses and start taking some actual real CS courses that you will actually enjoy. What's the Piazza post about? The Piazza post will be just a link to the slides for WebSockets and let you know, are you confused? Little shot, Leo, are you a sophomore? Yes, I am a sophomore. This is my second semester sophomore year. So I took 116 last semester.
Leo.
Yes.
Here's your post.
You made it? Or you're just sending it to me? Okay.
Okay.
Thank you.
If you're in Jesse's class, post 805 now has it.
This is late, but how's the campus? If you're talking about the actual UB campus, great campus. I love it. I miss it.
Yeah.
I go there once a week. It's a little empty right now, but man, the one semester that I was on campus, it was amazing. It's really good. I'm gonna be honest. When you are on campus and you got a lot of other people going to classes, it kind of makes you feel like, hey, everybody here is in the same boat. We're all doing college together, so that kind of helps a lot.
Am I a senior? No, I'm a junior,
technically
second semester junior. I have a really full beard.
Yeah, I wish my beard was as thick as Logan's.
Bro, it's been this way for a while.
Yeah, I know. I remember. I wish my beard can be as thick. Mine is just starting off.
8-hour drive. That sounds like you're from Long Island.
Either you're from Long Island or you're from New York
New
City.
York City. A drive Leo and I very well know about.
Oh, we very well know about that. I've never stepped foot on it. Hope for some tours or something.
Okay. We'll do this. Okay. During finals week, as a relaxer stream, we said we were going to do a relaxer stream, like of just like playing video games and stuff. We will do a virtual tour. I did this during lab last week with one of my groups when we were done. We did a virtual campus tour, and we kind of explained a bunch of stuff on like what campus is like, what's the good stuff on campus, that kind of stuff. We'll do a virtual campus tour.
Yeah, I will be down to do a virtual campus tour.
Taking 220 and 250 together, I hated it. Leo says it's okay.
Yeah, I say it's okay if you can time manage yourself really well. So I'm personally not doing good in 250, but that's only because the content is a little confusing to me. Other than that, it's a pretty interesting course. It goes way more in depth with your code than I would have liked, but it taught me so much about my code, so I personally enjoy it. So I would say do it if you want. If you see that it's too difficult, then you don't have to do it. Someone said they're from New York City. Yes, I am from New York City, but Logan is from Long Island. So,
I mean, both of us are from Forest Hills. Both of us from Queens.
I don't want to hear it from you, Logan. Stop it.
I was born in Forest Hills, man. What do you want from me?
That doesn't count. That doesn't count. You weren't born and raised there.
I was born and I was there for like 2 years, and then
2 years is nothing.
Yeah, I didn't have the choice to move to the suburbs, man. That wasn't my decision at 2 years old.
Yeah, pre-spoke, that's basically the same path that I'm on right now. Yeah, that's basically all it is.
All right, we're gonna get going. I know Leo's got work, and I definitely have work, so
yeah,
we're gonna get going. Remind us whenever we get to end of the semester that we will 100% do virtual campus tour and chill preview either last week of the semester, so like during finals week as like a kind of relaxing thing, or the first week of summer, because I
probably the week after finals week.
Week after finals week. We'll do it all during there. Virtual campus tour. We'll do Priests and I 1v1 mid lane. We'll do whatever games y'all want to play with us. We'll do it as a big group, and we'll probably have more people there because, well, there's it's the end of the semester. So, all right, we're getting going. Goodbye, everyone.